slideshow mode. There, by here. There, yeah. There, click that one.
Okay.
Okay, yes.
All right, maybe let me.
Can you start from the page? I need that page. Can we have your introduction page? Yeah, okay.
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 All right. Okay, thank you. Okay, my name is Engineer Nkosana Ndlovu. I'm from Civil Consult. I've been at Civil Consult for 10 years now, and I've worked in civil and structural engineering. Maybe to get into the way, basically the name Zimbabwe literally means houses of stone. So building in stone is something that is in our heritage and is something that we should revive. Additionally, there are several benefits that stone has for our current era. In addition to sustainability, cost effectiveness, it's also a great way to employ large numbers of relatively unskilled labor in putting our structures together in terms of infrastructure. Maybe going quickly, how can we make this practical in our current age in Zimbabwe? I think what we need to do is to use the modern standards and codes of practice, as well as modern tools to cut and shape the material. Some of these codes of practice, these are some British standards. These are basically highlighting the design of masonry structures, the general rules, structural fire design, that's the first one. Then BSEN 1996 Part 2, 2006, that's the design of masonry structures, design considerations, selection of materials, and execution of masonry. The third one is simplified calculation methods for unreinforced masonry structures. And the last one is recommendations for the design of masonry structures. There are also some tests, standards for testing stone material. Notably, there's BSEN 12372 of 2006, that's for flexural strength under constant moment. There's one on water absorption at atmospheric pressure. And more data on the tests and standards that are applicable can be found at englishstone.org.uk/document-standards.html. Well, in the previous discussion, we've had a look at, say, how we can have stone columns, but you can also have flat vaults that are not necessarily very massive in size. An interesting example which I had a look at was the shop at the St. Mary of the Resurrection Abbey in Jerusalem, completed in 2018 by AAU Anastas Architects. What you are seeing there is the flat vault, and it's supported on the edges by stone columns as well. Basically, you have stone voussoirs, which are stone cut sections that are put together as a puzzle and interlocked, and then you come up with a vault which is 12 meters by 12 meters, spanning the roof over the shop. And that is the final look of the design. It's notable that it feels contemporary. It doesn't feel like it's something that has been there for centuries, but it's all natural stone with a minimal use of maybe steel for threading the post-tensioning. So what I did here, after having a discussion with Steve and Amin, was we decided to have a look at a cost comparison to say if we built a similar structure to what they did in Clerkenwell, what would we get in terms of cost comparisons, in terms of using a stone frame instead of reinforced concrete columns. So here we are looking at the floor plate. There are external columns around the edges, and that's what we'll be considering. Maybe here we took it to be in general, maybe say 460 by 460. I had a discussion with the quantity surveyor, and he was saying that, well, in general, if you have a 460 by 460 millimeter concrete column, per meter run, that would come up to about $110.86 per meter rise of that column. That's US dollars. Then when we had a look at using a stone equivalent, his estimate came up to about $44.62. And that's just about half or less than half of what the equivalent cost in concrete would be. For maybe the entire structure, it would now be getting into detail if you're now going to look at, say, the location of the building, as well as the number of stories, and the hiring of a crane would also be considerable if you are to have a very tall, high-rise building. But from here, we can establish that there is a significant reason to investigate further the cost effectiveness of stone as compared to concrete. So when you look at the costs and also the environmental comparison, you get the picture that there is a benefits not just from sustainability, but also from cost effectiveness. I think in terms of the Zimbabwean context, we're also looking at avoiding the importation of steel for reinforcement. And once that is considered as well, there are benefits in terms of our balance of payments as a country, as well as for employing people as well. There are several quarries, and there are lots of, and the granite material is found plenty throughout the country, and this is something which I think would be of great value for us to explore in the Zimbabwean context. Also, with the view of going forward, sustainability will be a major issue, and this is how we can also tackle climate change. In a nutshell, that is what I've got to say. Maybe I can hand it over to maybe Steve for Q&A. That's the end.
Okay.
That's really very interesting. So very yeah. Sounds like it's a really good, I mean, in a Zimbabwean context, it sounds like it's a real win-win economically and sustainability.
Yes.
Wise. And certainly, I mean, we're also slightly concerned here about the increased use of machinery unemploying lots of people, just ending up with lots of people without jobs as a result of automation. And so industries that create good quality employment for stonemasons, I think also quite a good thing globally to create more employment. What should we do then? Should we just take questions? Anyone who wants to ask anything?
Yes, yes, thank you. My name is Innocent. I'm currently sitting in Johannesburg, South Africa. Thank you for your presentation, gentlemen, Steve, Annie, and Nkosana. It's quite interesting what the experience of Steve and Annie has shared with us, that this masonry construction can be revived in a massive way. And I think the positives are very clear about the carbon footprint in terms of sustainability. I think on the Zimbabwean context, it's also very clear that it can actually help a lot in creating employment. I think it's an intensive, labor-intensive kind of operation, even from your actually making your masonry blocks and stuff. So my question is first regarding the type of stone, to say, depending on the application. In your experience, which is the most suitable type of stone? I am asking from a civil engineering geological point of view. I am a novice in geology, but I know there are several types of rocks or occurrences of rocks, and I'm asking that perspective.
I mean, we in the UK we work with mainly limestone, some sandstone, and granite. And you know, granites, there are strong limestones and weak limestones, strong and weak granites. Granites tend to be a bit stronger. I imagine South Africa is rich in all kinds of rock, and in general, stones that we test are by and large limestone isn't the strongest stone. They're by and large far stronger than their kind of equivalent in concrete. I know it's Motopos, is that volcanic intrusion in Zimbabwe? You have a lot of granite and basalt. Is that right? So, yes. So that kind of material is ideal. I know a bit further up, East Africa and Kenya, they're using volcanic rock instead of in Kenya they're using, instead of concrete blocks, they're digging up stone blocks, which is from volcanic drift, I think, and they find it much cheaper to make stone blocks than concrete blocks for housing. I think you'll definitely have. I mean, Zimbabwe is kind of volcanic context, right? That's why you have all the olivine and stuff. So I think there'll be loads of stones there. Dolerites and basalts, they have strengths of 250, 300 newtons, even stronger than steel in compression.
I mean, Steve, maybe you can sort of help me with my thoughts on that. I mean, ultimately, the way we start is what's the easiest stone you can get hold of, cheapest, closest to you, that's available, i.e. there's actually quarries that are functioning, able to provide the quantities you want. And then work with an engineer on sizing. Once they test the stone for its strength, ability, sizing that stone accordingly. Now, we're building another one like this, like Clerkenwell, which is ground plus 5 stories in another part of London, but that's ground plus 10 stories. Now, it's simply a matter of increasing the column sizes and beam sizes to cope with that. However, in addition, in the UK, once you go up above 18 meters, it has to have a fire rating that's much longer. So the superstructure has to stay intact in the event of a fire to enable the firemen to go around the building, put the fire out, much longer than if it was ground plus 5 stories. So that means that the limestone has to be bigger, not just for supporting the building, but for the effects of heat on it. Now you can do that two ways. You can either make the superstructure an exoskeleton, so any heat hitting the superstructure surrounds the entire column and beam. That means there's no differential expansion in the column or beam. And that means that the column size only expands a little bit for purposes of fire as well as strength. Or if you're engaging the thermal envelope with the column, basically that means one side of the column is going to be insulated, or maybe two sides on a corner. which will encourage differential expansion. And to cope with that, the column will have to get a lot bigger. Now, that's if you're doing in limestone. If you can get basalt as easily, then the column does not have to be the same size as the limestone, because the basalt can cope with the heat. So you start off with, what are the local quarries? How can I get the material? How cheap is it? And at some point you do a cost comparison, which is, okay, my limestone column is now so big to be able to cope with the structure and the heat. The cost of that, of extracting and transporting and erecting that limestone, compared to if I chose basalt, which is a half the size, out of the two, it'll come down to cost. And then ultimately, you know, maybe your client might look at the appearance and say, I don't want the columns that big, I'd rather have them smaller. The basalt is a little bit more expensive. That's the sort of choice you make. So strictly speaking, whatever stone you like, and the engineer will help you manage the size of those stones. There's going to be an optimization balance at some point.
Okay, yeah, it's very good. I think, yeah, you've answered me, but you've also evoked one question more as you were explaining. In terms of the various stone types, in terms of, say, your limestone, your basalt, your granite, when you're looking at the finish, it's a facade. In this example, you gave us that you had to just leave the natural stone as it is, because you felt it was giving you that rich look. But I'm not sure, is it for like limestone? I know my little knowledge about limestone is that it's a carbonaceous stone that is subject to attack by acidic conditions. In context of that, how do you treat limestone when it is left to be exposed to the weather?
We do frost resistance. I mean, in the UK, frost is a problem, not so much in South Africa. We do frost resistance tests. We don't, some stones weather less well than others, but in general, there are many thousand-year-old, well, 700, 800-year-old limestone buildings that, and maybe after, you know, I would say like a typical 800-year-old Gothic cathedral in the UK maybe has a replacement of 20% of the components on the facade because of solution. So
yeah, and that's often not necessarily that's often the case because they weren't careful in how they place the grain, the sedimentary layer of the stone. So if you turn the sedimentary layer through 90 degrees and expose it to the weather, it wants to peel off layer by layer. And the Houses of Parliament that are only, you know, just over 100 years old, they suffer greatly with that because they were in a rush to build it and extracted the stone in a rush and weren't careful about which stone was laid like that or laid like that with a sedimentary layer. So there's a lot of that stone is just being replaced, as you say, because of weathering, rain weathering, and some of it's with pollutants. But if you're careful how you lay your stone, there's no reason why it shouldn't last 1,000 years. And hopefully I mean, how bad is the pollution in Harare? Is it or in South Africa, depending where you are?
It's rather minimal.
Can't be as bad as London. There are a lot of old limestone buildings in London, and London's been, you know, it's badly polluted now. It's been terribly polluted for 100 years, but in general, it's probably these houses fine. I wanted to add one thing, Nkosana's cost comparison. The columns were much cheaper in stone than in concrete. A beam would have much more rebar in it. And so I think that the cost comparison between reinforced concrete beams and reinforced stone beams will be even greater. There'll be a real saving for making beams out of stone.
True. It's just that we didn't. I decided to rush through things because I think we were behind on time. But I think if it holds for the column, it also holds even more so for the beam.
Yeah.
I think maybe I also wanted to add, there's a comment that perhaps maybe the real challenge in the Zimbabwean context would be to maybe to put together a group of people who would be interested in looking at stone, maybe to set up maybe a group of people who would work together to say, how do we work in stone? How do we train people to work in stone? And how do we develop the industry going forward? I think there's a lot of potential in that. And it's something I'll be looking at going forward.
Well, we'd be really totally happy to help.
Yeah.
Thank you.
Yeah, I think just one comment on the Zimbabwean situation, and vis-a-vis the modern issue of shaping the stones. Nkosana, how would you consider using natural occurring stone in its various shapes, which may not be very uniform, to constructing maybe low-cost housing? How would you take that? Because I feel that with the that would be very, very helpful in creating employment.
Can I jump in there?
Yeah.
When we looked at Clerkenwell, and even when we're looking at the 10-story, 11-story one in other parts of London, the quarries we went to, they're what can I say? They're almost a cottage industry. They're not the largest quarries. So there, they've got some very simple cutting tools and drills that split everything. On larger scale projects, so let's say you're doing low-cost housing, you're not going to build 1 or 2 houses at a time. You're likely to build maybe 100 houses, 50 houses, 100 houses, streets and streets of it. It's likely you'll go to a quarry that uses cutting tools and not any hand drilling. And there, you know, if you were looking for the rough, textured, aesthetic, highly aesthetic image, you won't get it, because those quarries literally cut the stone for you in pure, clean lines. So what you'll get is you'll get an optimized size of stone. So, for instance, they could look like no bigger than a cement block. And there, the decision you make is my labor and time so cheap in my local area that using them like concrete blocks is fine? Yeah, because obviously you might only lay 5 square meters a day with one person. So is my labor that cheap? I'll just use it like concrete blocks, and great. Then you don't have to worry about any aesthetic roughness. It's just simple, clean stone blocks. If the labor is quite expensive, so in the UK, that labor time is too much. So the main contractor will say, well, I don't want 5 square meters a day. I need 40 square meters a day. Well, what we're looking at is the stonemason in his yard receiving all the blocks well in advance of the day they're meant to be delivering them to site. And as Steve has described in his staircases, dropping holes through blocks and tying them together with tension cables. So you then get maybe 4 or 5 meter lengths of wall that are 2 meters tall on the back of a lorry, and they're just craned into place as if they're precast concrete panels. Now that obviously suddenly speeds up by you know, quite dramatically the installation time on site, if that's what you need, because your labor costs are that much. So I think it sort of answers your question in terms of aesthetics, i.e. you don't need to worry that it's all rough, but also answers possibly your questions on if it's affordable, how do you make it even more affordable, depending on your time, labor comparison, labor cost comparison.
I think the floor that we were making with the tiles, and I mean in the context of cheap labor, expensive materials, and I presume expensive plant as well. That actually you can build with that system, you can build quite a lot with very minimum plants, no form work, no floor work. You could build quite a big building just with manual labor. I think, you know, making the components the right size. I think in some situations where you're not dealing with big commercial buildings and you're dealing with housing or low-rise housing, that might be a good good solution in some ways.
Okay, thank you. I think I've got a gist, but Nkosana, maybe you had something to add on that.
Well, I think they covered it in great detail. I wouldn't want to add or subtract onto that.
Okay, thank you. I think my last comment is just to say there's been an interesting discussion, and Nkosana, I think I'm with you. Let's take the conversation and discussion on how to actually make it practical in the Zim situation with the help of these gentlemen that are doing it at a very high level, where they are creating a environment space for the rich, but we would want to target even the marginalized.
Yeah, yeah.
Thank you very much for having us. It's been a real pleasure to talk to all of you.
Been very nice. Yeah, and hopefully see you soon on another event.
And Dr. Banda, can you share with us all those presentations so that we can recap?
Thank you.
Great.
Thank you.
Okay.
Bye.
Goodbye, everyone.
Thank you. Bye-bye. Bye-bye. Bye-bye.